Hello everybody, it's Miss Talhami. We actually finished Unit 8 and we're moving on to Chapter 9. And Chapter 9 is all about quadratic functions. Now, quadratic functions is something that you've seen before in Algebra 1. So this should not be brand new to you. You should have seen this. We're just going to take it further, though, into, as we get further into the chapter, you'll see things you haven't seen before. But for now, we're just going to go back to the basics and see how much you remember. So to do that, I just want to talk about what a quadratic function is first. So most of you know the basic form of a quadratic quadratic function, and that's y equals x squared. That's the basic form, or sometimes we call that the parent function. So I'm going to actually start that and say that this is really sometimes called the parent function of a quadratic equation. Okay, now some of you also remember standard form. Now standard form is a little different. It looks like this. So where you have values in A, B, and C. So really what's important for you to note here, the key thing to know that it's a quadratic function is that we have this squared somewhere in the equation. So because we have that squared, it is a quadratic function or a quadratic equation. So what does the graph of a quadratic function look like? So some of you, if you go into your calculator and you put y equals x squared, you'll get a graph that looks something like this. And this is just a sketch. So just as a sketch, if you graph y equals x squared, this is what you get. If you do y equals negative x squared, oops. It would look like that. But both of them are quadratic functions. The only difference is because it's positive. So when it's positive x squared, it's open upwards. And then when it's a negative x squared, it's open downwards. And we'll talk about that more next time, but for now, this is the basic that you need to know. The shape of this function is called see if you remember, it starts with a P, a parabola. Parabola. So a parabola is the shape of this quadratic equation. So a positive x squared is upwards and a negative x squared opens downwards. The trick that I do to remember this is I say positive is like a smiley face. That's when you're positive. And then when you're negative, you have a frowny face. So you could see how the negative and the positive. So that's your way to remember when you have a positive x squared versus a negative x squared, what the graph would look like. Now there's two things I want us to focus on today. If we could focus on these two, then you're successful. One of those things is called the axis of symmetry. And that's a line. So sometimes they call it a line of symmetry. And what that is if you remember what symmetry means, is that it should look exactly the same on both sides. So if I fold it over, everything will match over perfectly. Almost like our hands. Our hands are symmetric because if I folded it over, or if I put my hands together, they would almost match up perfectly. Another symmetric shape could be a square. If I take a square and I fold it, it would be symmetric. So these are what a line of symmetry is. So I can draw you a square for you to see. If I had a square, here's a line of symmetry because it looks exactly the same. If I have that smiley face, if you look at that smiley face, here is the line of symmetry, looks exactly the same. Sometimes a line of symmetry, though, could be a different way. So if I have, like the letter E, a line of symmetry is this way. So a line of symmetry is if you fold it over, it looks like a mirror image on the other side, like as if I'm looking in a mirror. So that's what it means to be symmetric. And to be symmetric, there has to be some kind of line. So let's take a look at an example here. I'm going to just sketch an example. So, oops, excuse me. So I'm just sketching a random example. So here's a graph of an equation of a quadratic function or a parabola. So I'm just going to label it f of x because I don't have the equation. I just came up with this sketch. Now, to find the axis of symmetry, or the line, I want to find out if I draw a line here, right down the middle, where is that line? So if you take a look, this is the axis of symmetry. This is the line. Now, because the line is a vertical line, so because it's a vertical line, it's an x equals equation. And what is it passing through right here? X equals what here? X equals 3 is my axis of symmetry because that's the line that goes straight down the middle. The next vocabulary word I want you to focus on here is called the turning point or the vertex. Now in this example, because it's a smiley face, sometimes they call it the minimum because it's the smallest point. If it was something like this, it would be a maximum. So sometimes they call it a minimum or a maximum point. So it depends on which way, if it's a positive or a negative. So if I take a look at that point, it turns right here. So this is my turning point. That point, if you see, is a positive 3, negative 2. So that's how you find the turning point. Now these are very easy because I could look at the graph and get them. We will learn and use very soon and very shortly that there's actually mathematical ways to find the axis of symmetry and the vertex or the turning point. But for now, I just want you to see where it is. So that's really what I want you to learn today. So what I have for you here, I have 6 examples. Okay, and I'm going to number them for you because my mistake that I did not. So I'm going to number them. Here's 1, 2, 3, 4, 5, and 6. So in these 6 examples, I give you a graph, and I want you, it says here in the directions, with the following parabolas, find the axis of symmetry and the vertex. So look at each example, find the axis of symmetry and the vertex. So what I'm going to do is I'm going to pause the video. You should pause it too. I'm going to try and complete the questions. When you come back, I'll have all the answers for you. Okay? Okay, so hopefully you finished the problems. I just want to let you know that I've color coordinated them so that the axis of symmetry will always be in blue and the turning point or the vertex will always be in orange. Notice how every time I write the axis of symmetry, I write it as a line because it is a line of reflection. And when I write the vertex or the turning point, I write it as a coordinate because it's a point. Also notice that the x value will always be the same for the axis of symmetry. You see how it's x equals 1? So that means since that's the middle and the turning point's in the middle, the x has to be 1. So that's for number 1. Here's your answer for number 2. Here's your answer for number 3. Here's your answer for number 4. Here's your answer for number 5. And here's your answer for number 6. So again, if you have any questions, please make sure you reach out to me. Make sure you know the difference between an axis symmetry and a vertex. Have a great day, everybody. Hang in there. We are now at the end of May, and June is around the corner, and I believe we only have 8 more A days. Take care, everybody. Bye.